Okay, class, now let's talk about aldehydes. Some of you may have heard about aldehydes before, some of you may have not, but this class we're going to be going into aldehydes. So let's go over some examples where you may have come across aldehydes in everyday life. So if you have ever done any form of dissection before, these organisms are often preserved in something called formaldehyde, which is essentially a type of aldehyde that helps with the preservation of these organisms. And sometimes some perfumes or some colognes even have some form of aldehyde in them on top of any of the alcohol that they may have. So that's somewhere where you could potentially run into an aldehyde in your everyday life. Sometimes the flavor vanilla, when it's artificially created, also tends to contain an aldehyde. Okay, so what are aldehydes? Aldehydes are essentially a type of hydrocarbon, but they contain something called a formal group. So what is a formal group? A formal group looks something like this. So over here you can see a carbon that's double bonded to an oxygen, and that carbon is also bound to a hydrogen. And the rest of this molecule can go along in this way, but this is what a formal group looks like. It has a carbon that's double bonded to an oxygen, and the same carbon is also bound to a hydrogen, and that's what formal group is. And in order for it to be an aldehyde, this formal group has to be found at the end of a molecule. If the carbon double bonded to oxygen appears somewhere in the middle of the molecule, then it becomes something else called a ketone, which we'll go into later. But an aldehyde is found at the end of a molecule. Never. Okay. So let's draw an example, and the example that I have here is methanol. So I'm gonna draw methanol, and then for comparison, I will also draw methane. So over here, we can see that we have our formal group, which is our carbon double bonded to oxygen and a hydrogen. Here it can be any hydrogen. I'm just going to use this as an example. And if I were to show a comparison to methane, it looks like this, which is just carbon bound to 4 hydrogens, and methanol looks like this, which is just carbon bound to an oxygen. And here we can see a difference in this one. Our carbon is only single bonded to an oxygen, whereas over here, the carbon is double bonded to an oxygen. And to this oxygen, we also have a hydrogen that's bound, whereas this oxygen is not bound to anything except the carbon. And we can also see that methanol ends with an Al, which is key for us to know if it's an aldehyde or if it's something else. For example, methanol ends with an Ol, tells us that's an alcohol. Methanal ends with an Al, tells us that it's an aldehyde. Methane ends with an Ane, tells us it's an alkane. So how can we tell, or how can we name them? Again, very similar to the naming ideas for the other structures that we've gone through so far. So first we need to identify the root, which is finding the longest chain that includes the formal group. And this now becomes our parent alkane. And a trick that we could use is we can drop the e at the end to find the root of our aldehyde. And then we need to find the suffix, and the suffix, much like how we saw in the example before, would be al, which tells us that it's an aldehyde. And remember, the formal group is a carbon that's double bonded to an oxygen and also attached to a hydrogen. Okay, and since the formal group has to be found at the very end, that will always be our carbon number 1. So the numbering will be a little bit easier if you're confused about where to start. Just need to find where the formal group is. Um, to identify the prefix, all we have to do is name and give the position of any alkyl side group on the main chain as you would do for any other hydrocarbon. And remember, the formal group has to be carbon number 1 and the parent chain has to have the formal group on them. Okay, now let's go over an example. So over here I've drawn a particular aldehyde, and we know it's an aldehyde because we can see again the formal group, and the formal group is at the edge of the molecule. Now let's see if we can figure out the parent alkane. So this will be 1, 2, 3, 4. So we have a 4-carbon alkane. So if we were to write it simply as an alkane, we would get butane, not an H, butane. And the trick is you need to get rid of this E to find our root. So I'm just going to get rid of that E. So that would be our root. And the next thing is we need to put an AL at the end. So I'm going to put the AL at the end for our suffix because this is indeed an aldehyde. And then we need to look for any other side groups. In here we only have hydrogens, and so we don't have any side groups. So this molecule is called butanol. And remember, this is always carbon number 1 because we need to prioritize that. So if I were to number it, it will be 1, 2, 3, 4. Just so that there won't be any confusion. Okay. Now let's go over a little bit tougher example. So over here I've drawn a skeletal diagram of an aldehyde. And we know it's an aldehyde because we can see a formal group over here. And remember, this carbon at the edge over here is assumed to have the maximum number of hydrogen that's bound to it. And since this can form one more bond, because one bond gone this way, two more a bond goes this way, and it can form one more bond. So it's assumed that there's a hydrogen here, but in a skeletal diagram, you typically don't show the hydrogen. So we know this is an aldehyde because our formal group is right here. Okay, let's go over the steps involved in naming this. So step 1 says we need to find the root, and to find the root, we need to locate the longest chain that includes the formal group. So that'll be 1, 2, 3, 4, 5. That would be our longest chain. So I'm just going to draw a circle around it. And this is a 5-carbon chain, 1, 2, 3, 4, 5, which means our root will be pentane. And if you remember, the trick is that we drop the E at the edge. And this way we have our root. That's our root. And the next thing is we need to know the suffix, and the suffix is Al. And since this is carbon number 1, we can write the numbering in this particular order. So this will be carbon number 1, this will be carbon number 2, this will be carbon number 3, carbon number 4, carbon number 5. And our root will be Al. Now the next thing we need to worry about is the prefix. And for the prefix, we have one methyl over here and another methyl over here. So we have two methyls, and the two methyls, methyl over here, methyl over here, the two methyls are found in 3, 4, dimethyl. They're found in carbon number 3 and carbon number 4. And it's di because there is 2 of them. Okay, now if we were to put all of them together, I will write them in this particular way. 3, comma, 4 dimethyl pentanal. All right. That's all.